Hello, everybody. So in this video, I'm going to be discussing two-proportion hypothesis testing using Rguroo. So I'm going to go ahead and share my screen, and we will get started on our first example. All right, so here's our first example. A magazine claims that the proportion of women who are vegan is greater than the proportion of men who are vegan. Assume a sample of 120 women is taken and it is determined 20 of them are vegan, and a sample of 120 men is taken and it's determined 13 of them are vegan. So this is similar to means, it's just our symbols are different. So instead of mu1 and mu2, we have p1 and p2. So our null is that they're equal to each other. Since I told you women is greater than men, our alternative is greater than. And now I'm going to go to Rguroo and show you how to put it all in. So it's analytics, analysis, proportion inference, two populations. Now, we have a lot of different variables here. So the response label and the population label, you can just put what like your general variable is. So the general variable here would be like type of diet. And then we're considering a success to be vegan and a failure to be not vegan. Now down here, we're going to get more specific with our labels. We're going to label the variables specific to each population. So population 1 was women. So this is female type of diet. And then the other one is male type of diet. And then enter in our sample size and number of successes. So for women, we had 120 women, 20 of them are vegan. And for men, it was 120 and 13. Go under test of hypothesis, enter in your null. So it's going to be greater than 0. Check large sample Z. So this is the same format as the mu1 minus mu2 format. So it's always 0 in the box, and then you put the sign here. And then the significance level here is 0.1. Hit the eyeball. I'm getting a p-value of 0.0947. And then the OBSZ stat is the test statistic. So that p-value is less than the significance level, so we're going to reject. If we reject, that means we have enough evidence to say our alternative is true. So we have sufficient evidence to conclude that the proportion of women who are vegan is greater than the proportion of men who are vegan. All right, let's do another example. A study claims that the proportion of fast food restaurant B customers that recommend the restaurant is more than the proportion of fast food restaurant A customers that recommend the restaurant. And then we have our samples there. So I told you B is greater than A, but A is sample 1. So my alternative is actually going to be less than. If B is greater than A, that means A is less than B. Now I'm going to go to Rguroo and show you how to put it in. All right, so I'm just going to go under basics and edit what we had before. So our general variable here would be recommending a fast food restaurant. And then a success would be recommending. And a failure would be not recommending. All right, and then our label for, so we have restaurant A and we have restaurant B. So our variable for the first population would be restaurant A, recommend fast food restaurant, and then restaurant B, recommend fast food restaurant. And then we have for restaurant A, we have 200 as our sample size. And our number of successes is 65, I believe. Yep, and then for B, it's 170 and 58. And then go under test of hypothesis. It's going to be less than, and our significance level is 0.05, I believe. Yes. Large sample Z is still checked. Hit the eyeball. And I'm getting a p-value of 0.371. So that p-value is greater than our significance level, so that means we're going to fail to reject. If we fail to reject, that means we don't have enough evidence to say the alternative is true. So we don't have sufficient evidence to conclude that the proportion of fast food restaurant A customers that recommend the restaurant is less than the proportion of fast food restaurant B customers that recommend the restaurant. All right, let's do one more example like this, and then we're going to change it up a little bit. A political candidate believes the percentage of people that want to vote for him in District A is different than B. Then I gave you the two samples. So our alternative is going to have not equal to. Let's go to our Rguroo and put it in. All right, so our general variable here is voting choice. And then a success here is going to be voting for the candidate, and a failure would be against the candidate. All right, data summary. So this is going to be District A voting choice, and then the other one is District B voting choice. And then in District A, we heard that 230 people from District A were selected, 145 of them want to vote for him. So 230 and 145. And then for B, it is 230 and 100. And then test of hypothesis, changes to not equal to, and our significance level is 0.01. Then it's still large sample Z. Hit the eyeball. And I'm getting a p-value of 2.6 times 10 to the negative 5, which is basically 0. So that's the p-value in decimal form. I just took the decimal and counted 5 to the left. It's basically 0. That's less than the significance level, so we reject. Reject, that means we have enough evidence to say the alternative is true. So we have enough evidence to conclude that the proportion of people who want to vote for the candidate in District A is different than the proportion of people who want to vote for the candidate in District B. All right, let's go ahead and change it up a little bit. So now I'm giving you percentages. So you're going to do 0.52 times 300 and 0.57 times 300 to get your number of successes. But the Department of Education believes that the proportion of women who play at least one sport is different than men, so it's not equal to in the alternative. All right, so let's go to our Rguroo. All right, so the first thing is we need 52% of 300 and 57% of 300. So I'm going to open up the Desmos calculator here. So 0.52 times 300, that gets me 156. And then 0.57 times 300 gets me 171. So for the women, I'm going to have 156. For the men, I'm going to have 171. So let me go here. So our general variable here is playing sports in high school. And then a success, we're considering that they played at least one sport. And a failure is no sports. And I'm going to put the same general variable here. All right. And then, so for the label for population 1. So the variable here is women playing sports in high school. And the other one is men playing sports in high school. All right, so we had both sample sizes of 300. If you remember from our calculations, we had 156 for the women and 171 for the men. And then test of hypothesis, still not equal to, your significance level is 0.05. And then it's still large sample Z. Hit the eyeball, I'm getting a p-value of 0.219. That p-value is greater than our significance level, so we're going to fail to reject. If we fail to reject, that means we don't have enough evidence to say the alternative is true. So we don't have sufficient evidence to conclude that the proportion of women who played at least one sport in high school is different than the proportion of men who played at least one sport in high school. All right, let's do another example here. So researchers believe that the percentage of middle school children who are allergic to peanut butter is less than the elementary school children. So I'm telling you, middle school is less than elementary school. So we're going to use a less than sign in our alternative. And so I have 8% of 150. That's going to be my number of successes for the middle schoolers. And 14% of 150 is going to be for the elementary schoolers. So let's go to our Rguroo and put it all in. All right, so I said for middle schoolers, it was 8%, so that's 12 successes. For elementary schoolers, I said it was 14% of the 150. All right, so I have 12 successes for the middle schoolers, 21 for the elementary schoolers. All right, so our general variable here is going to be peanut butter allergy. And then a success, we're going to be that they are allergic, and a failure is not allergic. All right, and then this is going to be middle school peanut butter allergy. For this population, that's our variable for that population. And the other one is the variable for elementary schoolers. All right, so it's 150 is our sample size for both. And then I said we have 12 successes for middle schoolers and 21 for elementary schoolers. Go under test of hypothesis. It's going to be less than, and our significance level is 0.1. And then it's large sample Z still. Hit the eyeball. I'm getting a p-value 0.048. That p-value is less than our significance level. So that means that we are going to reject. And if we reject, that means we have enough evidence to say that the alternative is true. So we have sufficient evidence to conclude that the proportion of middle school children who are allergic to peanut butter is less than the proportion of elementary school children who are allergic to peanut butter. All right, let's do one more example here. Researchers believe the percentage of adults who are overweight in state B is less than the percentage of adults who are overweight in state A. Assume the researchers take a sample of 200 adults in state A and determine 34% of them are overweight, and they take a sample of 225 in state B and 32% of them are overweight. So we're going to have to do 34% of 200 for A and 32% of 225 for our successes for B. Now, I said that B is less than A, but A is sample 1, so our alternative is actually greater than. If B is less than A, that means A is greater than B. All right, let's go to our Rguroo and enter all this in. All right. So our general variable here is weight. We're considering a success to be overweight. We're considering a failure to be not overweight. And then I'll put my general variable here again. The variable for population 1 specifically would be state A weight. So that's our variable for our first population. Our variable for our second population is state B weight. All right, now we need to do our math here. So we had, for the state A, we had 34% of 200. That gets me 68. And then for state B, we had 32% of 225. That gets me 72. So I'm going to have 268 and then 225 and 72. All right, go under test of hypothesis. I am doing greater than, and my significance level is 0.01. And it's still large sample Z. Hit the eyeball, and I'm getting a p-value of 0.3307. So that p-value is greater than our significance level, so we're going to fail to reject. If we fail to reject, that means we don't have enough evidence to say the alternative is true. So we don't have enough evidence to conclude that the proportion of people in state A who are overweight is greater than the proportion of people in state B who are overweight. And that's it. So that's two proportion hypothesis testing using Rguroo. If you have any questions, please feel free to reach out.